Welcome everybody to our second webinar of the 2015 webinar series hosted by Greywater Action. I'm Laura Allen, and today's topic is plumbing for Greywater, Plumbing 101 for Greywater installers. I want to go do a few housekeeping notes before we get started. If you want to ask any questions anytime throughout the presentation, just type your question in the chat box on the left. And we'll be taking a couple of pauses in the presentation to answer questions. We'll also have time at the end to answer any remaining questions that you may have. Also, if you want to see a full screen version of the slideshow, you can put your mouse in the upper right corner of the presentation of the slide, and there'll be a little gray box, and you'll click on that, and you can get a full screen view. So now I want to welcome our presenter, Christina Bertea. She's a union-trained journeywoman plumber. She's been a plumber for a long time, and she's a very experienced Greywater installer and a Greywater Action instructor. So thank you so much, Christina, for joining us today, and we're going to get started. Welcome, Christina.
So thank you, Laura. This is exciting. This is my first webinar. And hello, everybody. It's interesting doing this virtually. What I'm going to try to do today is give you a very quick apprenticeship in the drainage system of typical residential houses. So what we're going to cover is the basic parts of the drainage system, how to identify the correct drain pipe that you would be cutting, how and where to put the three-way valve, how to cut the pipe to install it, connecting the three-way valve to the piping that you're going into, and then running new Greywater piping from the three-way valve out to the garden. So if you haven't done any plumbing, this is a whole new realm. For some of you, it will probably be familiar. So the drainage system, typically houses have a water system, a fuel gas system, and a drainage system. And the drainage system gathers together all the wastewater from all the fixtures in the building. And the fixture is a toilet, sink, tub, shower, washing machine, where fresh water enters and wastewater flows away. The size of the drain piping from any fixture is based on the anticipated volume of wastewater that flows through it. And what carries the water away in the drainage system is the fact that the pipes are all sloped. And the minimum amount of slope is 1/4 inch per foot. It's considered optimal for removing solids, which are not an issue that much in Greywater. And typically a single large drain carries the wastewater out of the building to join the sewer or flow by gravity to a sewage treatment plant, or to go out of the house and then go to a private septic system. So our next slide gives us a view of the different parts, which we'll talk about each one individually. So you have your fixture, you have the trap, you have a trap arm, a vent, a drain, and then the sewer. This just gives you an idea of what those parts are. I'm sorry I don't have a little red dot to wave around and point at things. So the trap is a really essential part of the drain system. It's required at each fixture, and what it does is it holds water that creates a water seal. And that prevents sewer gases and potentially vermin from coming into the house from the drain, from the sewer system or the septic system. So it's a really very important thing for protecting the indoor air quality of the home. So the vent, every trap must have a vent. And what the vent does is that it prevents the siphoning of the trap seal. And the way it does that is it equalizes the air pressure throughout the system so that if there's a sudden slug of water going through the drains, it doesn't create a vacuum and pull the water out of the trap seal and leave the house unprotected by that water seal. So the vents go up through the roof and allow air to come into the system. And another really important function they serve is that they allow air into the entire drainage system inside the home and then outside the home and in the sewers, and it prevents buildup of gases that could potentially explode. And that has actually happened. There was a story in the news quite a few years ago, Guadalajara. There were gases that built up in the sewer lines, and many streets blew up from the sewers. The drain, the drain lines underneath the streets just exploded because they weren't properly vented. Okay, so drains are sized according to the fixtures they serve. Typically, toilets require a 3-inch or sometimes a 4-inch drain pipe, and you will never be cutting a 3-inch or 4-inch drain pipe. So that's the most important thing you can get from this talk is that Greywater will be a smaller size drain in a typical home. Bathroom sinks will be typically 1.5-inch trap and drain. This is really more of a reference for use. We don't need to go through every detail. But bathtubs and showers that you will probably be working with are required to have a 2-inch horizontal drain. Washing machines have a 2-inch trap and drain. And it's important to know that in older buildings, sometimes these drains are undersized. Okay, so the next slide shows you pictures of leaded cast iron. The black pipe is leaded cast iron. And it's just showing you that, the main line in older homes is oftentimes cast iron, but the smaller pipes can be other pipe materials. So they could be galvanized or copper or even ABS. So just giving you a little intro to what you might see under a house. And this next slide, the drain materials, an important way to identify what kind of material your pipe is that you're going to be cutting is by looking at the way that it's connected, the way the fittings are connected. So with ABS plastic pipe, it has glued joints. With no-hub cast iron, it will have what are called no-hub bands. You can see there it has stainless steel wrapping around it with little nuts that you tighten onto it. Copper will have soldered joints, and galvanized steel will have threaded connections going into Durham fittings. So sometimes when you're under a house, it's really, really dirty. Everything is like dusty and has been there for a long time. And sometimes it's hard to identify anything by color. So looking at the way they're connected is the best way to identify the type of pipe. With copper pipe, the most important thing to remember is that you never, never, never want to cut a water line. Typically, water lines will be smaller than anything that you would be cutting. In most houses, they're 1/2 inch or 3/4, maybe in a new, larger house, 1 inch or even 1.25 inch, whereas you're probably not going to be cutting into a drain, waste, and vent Greywater line that would be less than 1.5 inches. So typically, a Greywater line would be either 1.5 inches or 2 inch. So, but it's just important to be aware that, making sure that it's not a water line. And water lines have markings on them that are either red letters, green letters, or blue letters, whereas drain, waste, and vent lines are required to have yellow letters on them. But again, when pipes are dirty, it's hard to see that sometimes. So, toilet drains. Toilet drains convey fecal matter, and that, by definition, makes the water in them black water, not gray water. And toilet drains will always be a minimum of 3 inches ID, and so, as I said before, you will never typically be cutting a 3-inch line. So that should protect you from ever cutting into a black water line. Typically, toilet drains will be cast iron or ABS. It's very rare to see a 3-inch copper or galvanized pipe, just because it's unwieldy working and more expensive to use such large pipe in that material. The vent is often of a different material than the drain when you're looking at a toilet drain. And older buildings oftentimes have a 4-inch cast iron stack that goes all the way up through the roof. And this picture here shows you that. You can see that the 4-inch continues on up through the floor, and that would go all the way up through the roof. And then the angle that goes over and up to the floor is going up to the toilet. So both the vent up and the closet vent are 4-inch. Okay, ABS toilet drains, which you will be finding in newer homes, oftentimes have the vent comes off of a 90. You can see the low heel 90, it's called, a 2-inch vent. So when you see that configuration, that 90 with the 3-inch 90 with a 2-inch coming off of the sort of the back of it, you know that that's not a Greywater line. That's not a sink drain or a washing machine drain or anything Greywater that you would be tapping into. So just to be aware of that when you see that particular fitting, that's a vent for a toilet. Okay, locating traps. It's helpful to know where the traps are located for different fixtures. So sinks typically have the trap right underneath the sink above the floor. So, it would either be in the cabinet that the sink sits in, or if it's a wall-hung sink, that would be visible right under the sink. With tubs and showers, the trap is going to be under the floor. That means that the tub and shower is upstairs on an upper story. That trap is going to be it's going to be in the ceiling above the lower floor and harder to get to. The toilet trap is inside the toilet, the actual toilet itself. And then the washer trap is inside the wall behind the washing machine. So just to kind of orient you, if you're looking for the trap of a particular fixture. So washing machine drains, the code requires them to have a 2-inch ABS trap in the wall above the floor. It's very particular. It's supposed to be between 6 and 18 inches above the floor inside the wall. Sometimes in older homes, they've adapted what used to be a laundry sink. They removed the laundry sink and then adapted that stub out to put a little trap on it for the washing machine. And those are often undersized. They're typically only 1.5 inches. So you will encounter that often. Okay, so most likely the Greywater that you're going to be piping that you're going to be searching for will be the tub shower, because that's oftentimes what people are going to want to divert out to their garden. So if you want to find a shower drain and you're underneath the house, you will be looking for a trap, a visible trap, because that trap will be located under the floor. So these are 2 examples. This is a schematic of probably a fiberglass shower pan showing how the trap connects underneath the floor and goes in the trap arm over to the drain. And then there's that photograph of an ABS trap going up through the plywood floor and connecting into a fiberglass shower pan. And you can see where they cut out the hole to allow the drain to go through the plywood floor, and that piece of plywood is still sitting on the pipe. Okay. So shower drains can be copper as well. The one on the left is a copper tailpiece coming down from the floor, going into the trap and over to the drain. And then on the right-hand side, it's PVC. So this is just giving you an idea of what you might see when you're looking for the shower drain piping. With the tub drain, the drawing on the left shows you kind of x-ray view of what's going on with the tub drain. You see the waste and overflow, it's called. You know how when you fill the tub, there's a little thing on the back of the front of the tub, up just below the top level of the tub, that allows water to flow out in case you've forgotten that you're filling the tub, and you don't want that overflowing onto your bathroom floor. So that's the overflow, and that goes down and joins the shoe that comes from the bottom of the tub and goes into a trap and over to the drain. And so what you'll be looking for underneath the floor in the crawl space would be the trap going up to that waste and overflow. So on the right-hand side, you see a cast iron, a leaded cast iron trap arm and trap, and a galvanized tailpiece going up to the tub. And these are just a couple more examples in the next slide. Locating the tub drain. Here you have, again, galvanized trap arm, a Durham P-trap, and a galvanized tailpiece going up to the tub. And on the right-hand side, and just an example of an ABS trap arm, an ABS trap going up to the tub. And the Greywater drain is immediately below where the trap arm connects into the riser. We'll talk more about these things later. Okay, so here's what you'll see when you get right underneath where the tailpiece goes up to the tub. You'll see an opening in the floor, and you can actually see the bottom of the tub usually. You'll see where the shoe that goes over and connects to the bottom of the tub, and then the brass riser goes up behind the back of the tub to the overflow. And so this is the way you confirm to yourself absolutely beyond any doubt that that is the tub pipe that you have located. So when you see that configuration of the waste and overflow going into the tailpiece going into the trap. Okay. So finding the correct drain for the work that you're going to be doing to capture gray water. I find it's always helpful to walk around upstairs and make a map in your head or on paper of where the different fixtures are located so that when you get underneath, you have a general idea where the bathroom is, say, in the house, or where the laundry room is in this house. And then when you're underneath, you know that your gray water lines are going to be smaller than 3-inch. If the pipe is 3-inch, that means it's almost certainly carrying black water with fecal matter from the toilet. And you know now that if you see a visible trap under the floor, that's most likely the shower or the tub. But to make absolutely sure that you've got the right pipe, the best thing to do is to run hot water through the fixture whose drain you're trying to locate. And if you feel that pipe that you think is the right one get hot, then you have that confirmation. And remember that the 2-inch toilet vent could conceivably be confused with a 2-inch washer or sink drain, and so make sure that you're not confusing that. Okay, so again, this is just this next slide, just showing sometimes it can be kind of confusing. Like, well, which pipe is it that's going to that particular spot that has the fixture that I want to capture the gray water? So running that hot water is really important. So this is probably a good spot to stop in and take a question if there are any, Laura.
There was one question about the trap, just to review that it prevents sewer gases from going into the building. So if anyone else has questions about the intro stuff, feel free to type them in now. I think we're good to go on a little bit more.
Okay. So once you've identified your the pipe that you pretty much confirmed beyond any doubt in your mind that you've got the right pipe that's going to the fixture that you want to capture the gray water from, then you need to decide where you're going to cut the pipe to insert the 3-way valve. So the code requires that the diverter valve be installed downstream from the vent. So it's not okay, according to the code, to install the gray water valve in the trap arm. And then there's always the issue of, in the drain, when you're actually in the drain downstream from the vent, is there space to even fit the 3-way valve? And this next slide explains that. So you see the tailpiece coming down from the tub. You see the trap arm. Those are both galvanized, and they go into that black pipe that drops down. That's the gray water drain right there. But it immediately joins a 3-inch vertical black water drain coming from the toilet. So there's absolutely no room to cut in a 3-way valve there. So in order to be able to capture gray water from that tub, you would have to majorly reconfigure that plumbing. And that's probably where you would want to hire a professional plumber to come in and do that, because it would involve really fussing around quite a bit to make space for your gray water valve. So we're talking about installing the 3-way valve downstream from the vent. So you can see here in this little drawing on the right-hand side, you've got your trap coming from the fixture. You've got your trap arm going horizontally over to the drain, which drops down The vertical line dropping down from that T is your drain. The vertical pipe going up is the vent. So that drop down is the correct place to put your diverter valve. In this case, this drawing is indicating that it joins Backwater when it hits the horizontal line. So you would have to do it in that vertical section. And on the left, you see a picture of a trap under a sink, and they've just cut into, made a little access panel in the wall behind the sink and installed the three-way valve right there so you can reach it easily just by going inside the wall and turning the handle. So that's in the correct location. Here's another example inside a cabinet. Again, you see the trap coming from the sink, the trap arm, the T with the vent going up and the drain coming down. And they've put the three-way valve in that drain downstream from the vent, and then the new piping goes out to the landscape. So that's correctly installed as well. So the tools that you would use to cut into the drain. It totally depends on what the material is. That's why we talked about identifying the kind of pipe that you're working with, because each type of pipe requires a different kind of tool. So when you're working with plastic pipe, you can use a tubing cutter, you can use a sawzall, you can use a handsaw. Handsaw is very practical because, it's pretty easy to cut plastic pipe. When you're dealing with galvanized pipe, you most likely want to for sure use a sawzall, or if you want to do it by hand, a hacksaw, but be prepared to spend some time. When you're cutting copper drainage, waste, and vent piping, you can use a tubing cutter with a copper wheel, a sawzall, or a hacksaw. Hacksaws have metal blades, so you wouldn't cut metal piping with a handsaw. And in cast iron, you would use a sawzall with a diamond blade in it, or some people like to use grinders with very thin wheels. That's kind of dependent on whether you have access all the way around the pipe to be able to maneuver the grinder all the way around. And then if you want to make a big investment, you could get a little mini snap cutter, but those are quite expensive. And so the picture on the right just has labels next to the different types of tools, so you have an idea what they are. So then we get to actually connecting the three-way valve. So with connecting, typically your three-way valve is going to be made out of plastic. It will probably be either a Jandy or a Pentair three-way valve. They're both plastic. And typically it will be able to receive an 1.5-inch ABS pipe inside the hub, or you could glue a coupling onto the hub and glue 2-inch ABS into the coupling. So that's one way to connect it if you're working with plastic pipe. If you're working with some other kind of pipe than plastic, you would use a transition coupling. Those join dissimilar materials or sizes, and we'll talk more about that in a minute. If you're going from your plastic three-way valve to either ABS, sometimes it's nice to have the option of being able to turn the valve or to spin it just a little bit. So if you don't want to glue it, you can use a no-hub coupling, which is designed technically for no-hub pipe, but since you're going plastic to plastic, you're not really making a transition, so you can also use no-hub couplings there. In situations where it's very tight and you can't roll back the rubber on a no-hub coupling, you could use a rubber slip coupling that will slide all the way back on the pipe because it doesn't have a stop in the middle. And so rubber slip couplings can be used in situations where it would be difficult to use another kind of coupling. And sometimes you'll find if you're working with no-hub cast iron or old leaded cast iron that you've cut to insert the three-way valve, sometimes the diameter of the pipe will be just slightly different, such that a regular band, a transition band, or a no-hub band won't work, and you will need to use a slip coupling in order to be able to get a good seal. So if you're using a Jandy three-way valve, you want to make certain that the three-way valve has been set so that the inlet is on the correct side where the incoming gray water is. And remember that it's required by the Greywater Code that you provide instructions to the homeowner how to manipulate the handle on the three-way valve so that they'll know, when the water is going to Greywater, when it's going to the sewer or septic. So remember to provide signage right next to the valve. Okay, now we're looking at we've just been talking about some of the different fittings that you can use for connecting the three-way valve. At the top there is an ABS plastic coupling, which could be glued onto the valve. The next one is the 2-inch no-hub coupling. It has those corrugated stainless shield around it. That could be used going ABS to ABS. If you're going from ABS to cast iron, or in other situations with ABS, you could use the slip coupling that I just described that doesn't have the stop in the middle. And then your transition couplings, where you can connect your 2-inch ABS to any other material, pipe of any other material or other size. And the tools with the bands that have the little nuts on them, you would use a nut driver or a torque wrench to tighten those nuts typically. And they're pictured in the right-hand corner there. Okay, transition couplings. They come in many, 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 many different options. So it's crucial to look at the little label, which is why I took this picture, so that it's big enough for you to see the labeling. They allow you to go from one size and material to another size and material when you're joining things together in a piping situation. So the one at the top, you can see that it's got a very narrow rubber band that goes inside that shield. That goes from 2-inch cast iron plastic or steel to 2-inch plastic or steel. It's called the CP200. It's your basic one. You can see that the next one below it, the rubber in the band is much thicker. That's because that one is it's transitioning from 2-inch to 1.5 inches. So it's letting you go from 2-inch cast iron plastic or steel to 1.5 inches cast iron plastic or steel. And that's why the band is thicker on the side that goes to 1.5 inches. That's called a CP215. The bottom one, CK, always indicates that it's going to copper. So it's a CK115. It's going from 1.5 inches cast iron plastic or steel to 1.5 inches copper. So that's just to kind of orient you to the types of transition couplings there are. Okay, here's an example of different choices here. You can see on the right-hand side we've used an ABS coupling to join 2-inch ABS pipe, gluing it to the outside of the hub there on the three-way valve. On the left side, that's a slip coupling, also goes over the hub. Hello? Oh. And in the bottom one, 1.5 inch ABS pipe is glued into the hub. I'm getting a beeping, and I'm not sure why.
Christina, I can hear you. Just so you know, you're okay.
Okay. Okay, in the next picture, we have, this is just showing you the three-way valve actually installed under a house. This is leaded cast iron, so we've cut the cast iron with a Sawzall and taken out the piece and used these transition couplings that go from 2-inch plastic to 2-inch cast iron. And then on the side going to the garden, in this case we use 1.5 inch ABS, and so there's a transition coupling that reduces down to the 1.5 inch ABS. So. Okay, the following picture shows, in this case, the tub drain was 1.5 inch copper, DWV copper. So what we did here was the three-way valve has 1.5 inch ABS stubs glued into it, and then used the CK transition couplings that go from 1.5 inch ABS to 1.5 inch copper. So we could have used the 2-inch plastic by 1.5 inch copper. Anyway, there's always several ways to do anything. And notice that this has the actuator attached to it so that they could operate this from inside the garage instead of having to go into the crawl space. Okay, here's a picture of another valve that's installed. On the right-hand side, it's a actually that's a no-hub band because it's going from plastic to plastic, 2-inch to 2-inch. On the left-hand side, there are slip couplings with a check valve in between, and this raises the issue of the code in many places wants you to install a backwater valve that prevents any kind of sewage backup from being able to reach the three-way valve. So the check valve or backwater valve basically only allows water to flow one direction. So the shower water coming from the right-hand side can flow through the three-way valve and through that, in that case here, pictured check valve. But if there was sewage trying to come back, the check valve would prevent it from going to the three-way valve. And there's a picture here, and the small picture is of the approved fitting backwater valve with an actual cleanout on the top. So just be aware. This can make it more complicated. Remember we talked about sometimes there's not space for a three-way valve, that the Greywater piping connects to the Backwater piping too quickly to have room to put a three-way valve in. Well, if you need to install backflow prevention, that means you have to have even a longer section of pipe that you can cut out to be able to install both of those, both the backwater valve and the three-way valve. So it can make things a little more challenging. So labeling, we mentioned before, you always want to label the three-way valve so that anyone who was looking at it would know how to make the Greywater go to the garden or make it go back to the sewer or the septic. And typically the image, here we took pictures of the valve handle in both positions. It's easiest to just indicate that the valve handle, when it's pointed one way, directs it to one place, and when it's pointed the other way, it directs it to the other place. And so this is just showing it's nice to have images like that and then to get it laminated so that if it's in a dusty or damp location, it's not going to deteriorate. So. Okay, here's another example of labeling. You can see the three-way valve and then the piping, the new piping that's going out to the garden. And there's been a hand-drawn label posted right near the valve, again, so that people will know how to operate it. And remember that any piping you're going to be installing to the garden has to have that continuous 1/4 of an inch per foot slope, and you need to be able to pass over or go through the perimeter foundation. We'll talk more about those things. Okay, is this a good place to stop for questions, Laura, if there are any?
Yeah, we have a couple of questions.
Okay.
So the first question is about where to divert the water. This person has their shower drain is first, and the second sink, let me just read it. It says, if my plumbing is structured with shower drain first, then sink second, where the vent is, then the drainage goes to meet the toilet. If I only want the shower for Greywater, do I need to set up a new vent connection upstream, since the three-way valve will be in between the shower and the sink?
Oh, they didn't plumb it with a separate vent for the shower, is what I'm gathering. Well, technically, every trap is supposed to have a vent, so that shower doesn't have a vent. So, this is tricky because you're working on existing plumbing that may not have been done correctly. If it's going to be inspected, who knows what the inspector might say. He might say that there's supposed to be a vent between the shower trap and the three-way valve. That's the correct way to do it. It would be difficult to run a vent and have it connect because it's supposed to connect to the bathroom sink vent above the flood level rim of the bathroom sink, which would mean you'd have to be able to get up into the wall to connect those vents, which would be inconvenient at the very least. So I guess in that case it would be a question of, is it going to be inspected? What are the ramifications of putting that three-way valve in between the shower trap and the vent? It could conceivably result in the shower drain draining more slowly, but actually, when the three-way valve is directing the water to the garden, I'm just thinking there's probably a certain amount of air coming in through the pipe itself. That's an interesting. It's always tricky when you encounter plumbing that isn't quite up to snuff, and you're trying to add something to it. Then those decisions that you make. Laura, do you have anything else to say about that?
Yeah, just to add that on the Greywater, when you're diverting water to a Greywater system, there are no sewer gases in that system.
Mm-hmm.
So the kind of main function of the trap-in vent is to protect the home from sewer gas. So you don't have to consider that. You do have code and permitting if you're getting a permit, but if you're just asking about functionality and safety, it's functional and safe to not have a vent and a trap on a Greywater drain because there is no sewer gas. But that may be in contradiction to what the code says. So like what Christina said, permit or no permit will determine a lot. And then there's another question, Christina. It says, is it best to install the actuator when you install the three-way valve, or can we install it later on?
I don't think it matters when you install it. I don't think that it's, I guess it would be a question of how difficult is it to get to the location where the three-way valve is, and would it be just easier to do it all at once? Sometimes, and you need to remember that you need to leave space for the actuator. I mean, that would be something to keep in mind if you are planning on doing it later, that you install the valve, particularly if you're gluing it in place. Make sure that you install the valve anticipating the size of the actuator that's going to be installed later. And there's can be some little tricky adjustments that are made to the inside the actuator to set it right. And so I'm not sure, Laura, do you think it's easier to do that all at the same time, or even when you have the valve not installed yet?
It kind of just depends. So I think either one. If you already put in your valve and want to do an actuator, no problem. If you're going to do it all, in general, it's easier to keep your projects, start and finish them all together. But either way, it usually works. Yeah. Okay. And I'm going to recap what the actuator is. There was some people lost the phone connection. Sorry about that. But the recording, you can go back and read it. So the actuator, for people who missed that, it motorizes the valve, so you can control the valve by a switch inside the home. So it's just a motor that attaches right to the valve that's plugged in, and then you have a switch in the home. And there is one more question, and then we'll go on and do more questions at the end. So the last question was, if you're planning new construction with a slab on grade construction, can the three-way valve go below the slab?
Oh, read that again. Yeah.
Sure. So new construction is often built slab on grade, so people want to put in a three-way valve when they're planning their new construction. So where should that valve go if their shower pipes are going to be in the slab?
Wow, interesting. You would have to have an access panel. If you were going to try to do that, you would have to have an access panel somewhere in the floor where you could get to that three-way valve. For people who are doing remodels and doing slabs, oftentimes what they'll do is plumb the Greywater to the outside and then have the valve outside in an access panel before the Greywater joins the Backwater line. So it's really depends so much on the particular design and how the rest of the plumbing is running. And but yeah, the three-way valve would have to be accessible, at all times in the future. So I don't know, could be in a closet. You'd have a hole in the, basically you'd frame out an area in the slab that would be open on top, so you would have permanent access to that valve. It's I don't know. Any other ideas, Laura?
A cost issue. If it's cheaper to do it that way, do it that way. Or if it's cheaper to just run the pipe outside and then put in
Yeah.
out underneath the build or outside in the ground, you would have the access area.
I think it's possible running it outside is better, but yeah.
Yeah.
I don't know. So much depends on the layout, and how far it is from a exterior wall, et cetera. So. Yeah.
Okay, so why don't we, we'll go through the rest and then we'll do more questions at the end.
Okay. So now we're ready. We've got the valve in. We've learned all about the different fittings and ways to connect it, and we got the right pipe. And so now we're doing real plumbing. We're running new piping out to the garden. So typically it's going to be either 1.5 or 2-inch ABS. If you're getting a permit and it's for a shower or a tub, it will need to be 2-inch because that's the minimum size for a horizontal drain for a tub and shower. So we're going to talk about the fittings that you'll be using, how to support the pipe, the slope, having cleanouts, and then testing. So there's a lot of terminology in plumbing, and we're just going to review it real quick. There's outside diameter, inside diameter, male and female, hub, spigot, street, sweep radius, direction of flow, elbows and bends, T's and branched fittings. And you will know all about those in a minute. So this is a Pentair 3-way valve, and you can see that because there is a thickness to the hub wall, the inside diameter is going to be smaller than the outside diameter. So that's why we talk about inside and outside diameters when we're talking about plumbing. Typically a hub, you can see the 90 on the left has 2 hubs, and that would receive a pipe being glued into it. But there are also fittings that are called street fittings that have one end that is actually the same size as pipe. It's not a hub. It's the same outside diameter as the pipe, and it can actually glue straight into the hub of another fitting. And in a tight space, that's really invaluable. So it's really good to know about street fittings. So street fitting has hubs, but it does have one end that does have a spigot end that can glue into a hub of another fitting. Okay, when we talk about sweep or radius, we're talking about basically how gradual of a curve it is in the turn of the fitting. And so you can see up at the top, that little 90-degree turn has absolutely no sweep or radius at all. It's a sharp 90 degree. That fitting can only be used for air because it really doesn't allow a smooth flow of liquid. The middle fitting is called a short sweep fitting, and it's only allowed to be used where the flow is coming horizontally and then dropping downwards vertically. So it's only for horizontal to vertical. It's called a short sweep or a sanitary fitting. And then your long sweep fitting at the bottom you can see it has quite a nice curve, quite a nice, easy, smooth flow. That can be used in any position. It can be used flat, horizontal to horizontal. It can be used vertical to horizontal. It's the most versatile fitting. So direction of flow, we're getting into, is it going vertical to horizontal, horizontal to vertical, et cetera. With your fittings that have no sweep, the ones at the top there, those are for air only, not used for liquids. Those are vent fittings. We just talked about sanitary or short sweep fittings. Both the T and the 90 can only be used where the flow is horizontal to vertical, as pictured here. And then when you're talking about water that is falling from a vertical pipe and then joining a horizontal pipe, in plumbing where there are solids being conveyed, you can imagine that would be a spot where the solids could accumulate. And so the plumbing code requires that liquids, that fittings that are receiving vertical flow and then directing it into horizontal flow must have that flow enter on a 45-degree angle to the horizontal. So the top picture of 2 fittings, that's called a combination. It's a 45-degree, a street 45 actually, that glues right into the hub of that Y. And then below that is an actual combination where the fitting has already been molded as if it was those 2 fittings combined. And then the sanitary T, which you cannot use on its back like that because the liquid is not entering on a 45-degree angle. And you cannot use the short sweep 90 in that position either. So these are all for your reference. You probably won't remember this all up front, but okay, so we're talking about the names of fittings. When you have a branched fitting, that will either be a T, or we just mentioned the Y and the combination. And so you can see those pictured here. When we're talking about fittings that bend the direction of the pipe, if it's a coupling, it just joins the pipe and the pipe goes straight. So imagine a coupling just having the pipe go up vertically. The smallest fitting, a 22, would bend that straight pipe over 22 degrees. A 45 bends it a little further over 45 degrees, etc., 60 degrees. So it's how far it's bending it from a straight line. So that's why they're called bends. So they're also described as a fraction of a circle. So you have, a 45 would be an eighth bend, and a 90 would be a quarter bend. So this is all just kind of learning the language here. And then when you have a T, you have the run, which goes straight through, the straight line through the fitting, and then the branch is the side outlet. And typically when you're trying to find something online, the way that you would name it, you would name the run first with the larger end first, and then the other end, and then name the branch, and then say what the material is. So this is a 2 by 1.5 by 1.5 sanitary T, ABS sanitary T. Okay, so double L's you will be using in branch drain systems if that's the kind of greywater you're installing. And as we said, if it's a permitted system, from a shower or a tub, it will be 2 inches coming out to the garden, and you can drop into a 2-inch by 1.5 by 1.5 double L, and that way you have 2-inch going all the way up to that first split. And then after that, you can use just regular 1.5 double L's, where all 3 openings are 1.5. And we like to drill a hole in the double L's and use a metal nipple to create threads in the hole, and then screw in a PVC plug. And that way you can actually look inside the fitting and use that as a little cleanout, because sometimes hair or gunk will accumulate right in that little spot where the double L splits. Okay, a really, really important part of using ABS pipe is supporting it properly. And I can't tell you as a plumber how much terrible ABS I see installed. People in general do not properly strap ABS pipe. The code requires that it be supported every 4 feet, and the proper way to support it is to have a rigid pipe hanger. You can see 3 examples of those. There's a rigid rod, and either like a little loop thing that you pull tight around the pipe, or there's a J hanger there that you can. These are all typically screwed or nailed into the framing under the house. If you can use ABS perforated plumber's tape. It's plastic tape. You cannot support the pipe with that. You cannot hang it from that, but you could use that to hold it tight against something or to stabilize it. And if you want to use a tool-hole strap, which is the little gray ones down there at the bottom of the picture, technically you're not supposed to use metal strapping on plastic pipe. So with ABS, you can get the electrical tool-hole straps that are made out of plastic and use those on your pipe. Or if you really only have metal tool-hole straps and you just really need to use it, you can put 10 mil tape around the pipe to protect it. Because the idea is that as that pipe expands and contracts, it's going to move slightly in that hanger. If it's a metal hanger, it could conceivably abrade the pipe. So that's the reasoning for that. And this next slide is just showing you, it looks very professional if you use the proper rigid hangers. And plus which they're very easy to use. Your framing is going to give you the option of putting a rigid hanger every 4 feet, and you just cut them. They have markings on them. You just cut them 1 inch shorter each time. So it's really easy to just get your pipe at the right slope just by using that rigid rod and screwing it or nailing it into the framing. Here's another picture just showing you. If you want your work to look professional, this is definitely the way to go. A lot of people don't use them because they're expensive, but personally, I think that Greywater needs to be elevated into the class of being really professional work. And if an inspector sees that you have properly hung your pipe, it's going to make a big difference in their attitude, I think. Plus which it's the right way to do it, because what it does is it prevents, in an earthquake, it prevents those pipes from being able to bounce up. It keeps them from moving sideways, but it also keeps them from bouncing up. So, and if your rod, the hanger rod isn't long enough, you can add a 2x4, as is pictured on the right. So, okay, so when you're trying to figure out the slope, if you don't have the convenience of just cutting your rod 1 inch shorter each time you connect it every 4 feet, then you'll be using your level to determine slope. And typically you'll probably be using a little torpedo level, that's like the one pictured here, or maybe a 2-foot level. And you could just for your own knowledge, you could calibrate it using a block of wood and determining, setting it up so you have a 1/4 of an inch grade, and then putting your level on there and learning where on that level is going to be your 1/4 inch slope. And some levels that you buy actually already have it marked in where the little glass opening is. It will actually show you where that percent of slope is for your bubble. If it's at that line, that would give you the correct slope. Okay, cleanouts. The code requires that you be able to get into the piping to clean it out in case there's a blockage. And the rules for locating cleanouts is that they have to be installed every 100 feet of pipe, or when there's an accumulated number of bends that add up to 135 degrees. So if you have, for instance, a 90-degree bend and a 45-degree bend, that gives you 135 degrees. So the next time you install the bend, you would have to have a cleanout there. So they talk about it being an aggregate number adding up to 135. So, and the cleanout has to be accessible. So it's not going to do any good if it's somewhere where nobody can reach it, or it's like right up against the wall. You're supposed to have 2 feet in front of it that you can reach it from. And like we said, in the double L's outside, we like to put that little plug that kind of acts informally as a cleanout. When I have my Greywater coming out the sidewall, I've done all my strapping underneath the house, and I'm finally coming out of the house and going to the garden. Rather than just dropping down with a 90, I like to use a sanitary T there. Remember, sanitary T you can use where you have horizontal going to vertical. And I do that because I can put a cleanout right there at the top of that T. And then if I want to, rather than going inside and turning on the water to test my system or just, see how it's all running, I can just put a hose into it outside. Or later on, if I think maybe there's been some accumulation of slime or hair or whatever, I can use a hose to blast out the system. So I think it's really nice to use that T when you're coming out of the wall before you drop down into the ground. So so you've finished running your new piping, and you've strapped it impeccably, and you've got your pipe going out into the garden, and you've got it all installed out in the garden. Then I believe that all that should be necessary is a running test. Hopefully you won't run into an inspector who's going to require some more complex kind of testing. But if you do a running test, have the water from the fixture that you are capturing the Greywater from running through the whole system. Really important to check for leaks underneath the house, because obviously you don't want to be responsible for something that could create problems in the future. And even though you may absolutely trust your own workmanship, it's important to know that materials can have defects. And so what you're checking as much as your own work is the materials that you've used, because sometimes they will have holes in them or some other problem that you would never imagine. And sometimes, you can forget to tighten a band, or maybe the band is tight, but the cast iron was rough and it didn't actually seal properly. So you definitely want to catch any problems before before you're finished with the job. And then if you're working with glued pipe, it's a good idea to check how long the manufacturer suggests letting it set before you test. Although a running test isn't actually pressure, but anyway, just a good idea to glance at how much time is suggested to be allowed for the glue to dry. So that's pretty much what we've got going here. That's it. So maybe there's some more questions.
There are, and I just want to clarify that this is the plumbing portion, and then after this there's the irrigation system, which is a whole other part of Greywater. And we have upcoming webinars to address different ways of using that water through the gravity flow branch drain system that Christina mentioned. We'll have pump systems coming up, not at this portion of the webinar, but next year we'll have some more talks on all different ways to use that water once you get it diverted away from the sewer system. So back to the questions. There was a question about when you split the flow in a branch drain system, you're running in the 2-inch ABS pipe, and you can later cut down to 1.5 inches. And you did mention that, Christina. I just want to clarify that if you can't get that cool 2-inch by 1.5 inch diverter or double L valve, you can just, after your first split, then you can go into the 1.5 inch ones after that.
I mean, just use it to...
Like
just
first use a
2-inch,
and then next use the 1.5 inch.
Okay.
So you can, an inspector would allow you anytime, as long as you do your first split in 2 inch. There's a question about, would you typically get an electrician to install the electrical for an actuator, or is that something a plumber can typically do?
Well, I imagine you're going to be providing really good instructions, and I believe there's instructions on our website too. Are there not, for actuator? As long as there's an outlet, you do need to be able to plug in the transformer, and then there's wiring that goes to wherever the switch is located. So it's more a matter of whether there's actually an outlet nearby or an appropriate location to be able to plug in the transformer. If there isn't an outlet, then that's probably something that you would get an electrician to do. But the actual wiring of the low voltage wiring from the transformer to the switch is something that we typically do. So.
And we will be having a class on actuators next year, so if you want to get that. So there's another question about some upcoming things. Will drawing up plans for permits be covered in another webinar? And we're going to have a webinar on codes and permits, and we'll share examples. The permit requirements vary greatly around the state and especially across states, so it's hard to really generalize. And there's one more question about kind of a more business type question. So I'm going to just do our little quick closing, and then we'll answer that question. So if you ask that question, stay on the line. And if you want to stay and listen, you are all welcome to. And please type in more questions if you have them. But I just want to thank everyone for attending, and especially thank Christina for your excellent presentation. And I want to remind people that you can view this as a recording. You'll get the recording in about a day or so, and we have the rest of the series to look forward to. So thanks for coming, everybody, and we'll see you next time. And we'll go to that last question. So this is about a business question. If you want to be installing Greywater systems for neighbors and friends and you want to charge, what do you need to do? So that's kind of one question. And then the second question is, can you talk about being a dirty person plumber and or hiring a contractor to consult sign off for such a small business?
Okay, well, the first question, so if you want to do it for friends and, was it neighbors?
Friends and neighbors.
So that, and you want to charge for them, then that's probably a situation where you wouldn't have to be so concerned about the minimum amount that you can charge and not have a contractor's license. Like, I believe it's either $500 or $600. Anything over that, you're supposed to have a contractor's license to do a job for somebody. But if you are doing them for friends and neighbors, then that probably wouldn't be, hopefully that wouldn't be an issue.
Yeah, just to jump in, I mean, technically, it doesn't matter if they're your friend or your neighbor, you're still under California contract law.
Yeah.
So friends and neighbors often do, kind of more mutual aid, like helping each other out in more alternative economies. But yeah, there is California contract law, like Christina said, but $500.
It is $500 now. It used to be $600, which is challenging if it's a branch drain system. Oftentimes it costs a little more than that. And the second question, what was that again?
That was it's kind of more about partnerships. So can you talk about being a journey person plumber and or hiring a contractor to consult? So if somebody had a small business and they wanted to partner with a plumber or a contractor, can you talk a bit about that? Like, how would they go about doing that?
Well, it would be, when you use the word partner, that is a little vague to me. I mean, I can imagine that you could have an arrangement where you would just hire the contractor. If you were trying to have it be some kind of mutual, I'm just trying to visualize what that would be like. I mean, I guess. Let
me rephrase it, because I actually used the word partner. The question did not use that word. I'll read it. Can you talk about being a journey person plumber and or hiring a contractor to consult / sign off for such a small business?
Okay, I'll start with journey person. So the journey person plumber refers to when I was working in the union. It refers to the fact that I completed a 4-year apprenticeship and then was, quote unquote, turned out as a journey person. Then years later, I got a contractor's license, which was a whole separate thing from the union. And as a contractor, I do Greywater jobs myself, so I haven't been in the position of needing to hire a plumbing contractor. I'm just trying to, getting someone to sign off. So I suppose you could have an arrangement with a plumber that you knew who you could consult with. I would say it would probably be some kind of hourly wage that you would give them to help you design the system. Then you might install it yourself. Then perhaps they would come and double check it and make sure that it's up to snuff so that it would pass inspection. That would be a matter of creating a relationship with some plumber that you liked and trusted, and who would be willing to do kind of informal, something that wouldn't be a big time commitment. I suppose if somebody developed a really serious Greywater business and they did not have a contractor's license, then sometimes people make arrangements where the contractor, they can kind of work under the contractor's license. I've never actually personally done that with anybody, so I'm not sure what's involved in that, but I believe it's possible for contractors to sort of give, to have people under their umbrella, and I'm not the person to ask about that because, as I said, I'm not really clear about how that works, but that's probably, if I were wanting to be a really high-powered Greywater installer, doing lots and lots of systems and ones that involved technical plumbing, then I would probably look to, if I was going to do the plumbing myself, and I knew enough about plumbing to do it myself, I would try to get some contractor to have that arrangement with me where I was working under their license. I don't know what kind of contractual arrangement that would be. I'm not being very helpful.
That's kind of a common thing for people to have partnerships and hire like a more generalist gardener, landscaper. Might do greywater work, and they might have a plumber that they hire, so they would just hire them kind of independently to do a particular portion of the job. That's one way. But yeah, there's lots of different ways, and since greywater is an emerging industry, people are figuring out what works for them and in their business and with their skill set. So I think we'll end there, and we went a couple minutes over, but that's totally fine. And if people have more questions, they can send them in for the next time. And also just send any questions you have to our Greywater Action has a forum, and you can post any questions you have there, and we'll make sure they get answered. So thanks again, everybody, and we'll see you next time. And thanks again, Christina.
Thank you.